What is flux core welding? Flux core is an arc welding process that uses a tubular wire electrode with a flux-filled inner core. The American Welding Society calls this process flux cored arc welding, or FCAW. All flux core welding is done on equipment that is similar to, and sometimes identical to, the equipment used in MIG or gas metal arc welding. If you're not familiar with MIG welding, you might want to watch our What is MIG Welding video before continuing. But you should understand that flux core welding has some important differences from MIG welding. In flux core welding, the wire electrode is fed through a wire feed unit. Usually, this wire feeder requires knurled rollers that can grip the tubular wire without flattening or damaging it. As in MIG welding, an electric arc forms between this wire electrode and the workpiece. This arc heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in the parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. Because the wire electrode melts as it's being used, flux core is called a consumable electrode process. Flux core welding always adds filler metal to the joint. The job of the flux inside the electrode depends on which type of flux core process it was designed for. You see, there are two main types of flux core arc welding: self-shielded, known as FCAWS, and gas-shielded, known as FCAWG. You need to be sure you're using the wire in the way that it was designed to be used, because the chemistry behind these two processes is different. Flux-cored electrodes that are designed to be self-shielded contain a flux that completely protects the molten weld pool. The flux in these electrodes creates a protective cloud that prevents gases like nitrogen and oxygen from reacting with the hot metal. One advantage of the self-shielded flux core process is that the added cost and inconvenience of gas shielding equipment is eliminated. Also, self-shielded electrodes are less sensitive to drafts and breezes that easily contaminate gas-shielded processes like MIG welding. This can be a real advantage in some applications. Electrodes designed to be gas-shielded rely on a secondary shielding gas to do the job of protecting the molten weld. The high-pressure gas cylinders used for this process are of the same design as those used in MIG or TIG welding. These cylinders contain gas under extremely high pressure, and a device called a regulator brings the gas to a usable pressure. One of the most common gases used to shield flux core is pure CO2. Other gases, such as CO2 argon blends, are also used. But one advantage of flux core G is that low-cost CO2 can be used to shield the weld. Another benefit of gas-shielded flux core is the high deposition rate that can be achieved with the combination of flux and gas. Gas-shielded flux core has the ability to lay down metal at an extremely fast rate. In both the self-shielded and gas-shielded processes, the flux forms a thin layer of slag that protects the weld as it cools. This slag also helps the solidifying weld to take a consistent low-profile shape. In flux core welding, all of the machine controls are set on the machine itself. The most important of these are polarity, wire speed, and voltage. The trigger on the gun is just an on-off switch. For most flux core welding, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always negative and one is always positive. In self-shielded flux core welding, the electrode is usually negative and the workpiece is positive. The term DCEN is used for this, indicating that the current is DC and the electrode is negative. You might also hear this called straight polarity. In gas-shielded flux core welding, the electrode is usually positive and the workpiece negative. The term for this is DCEP, indicating that the current is DC and the electrode is positive. This is also called reverse polarity, but DCEP is a more descriptive term. Keep in mind that these are the most common settings, and always check your manufacturer's recommendations. In an electric circuit, the current flows in a loop. In flux core welding, the current has to flow in a complete circle from the machine to the gun, into the work and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. So in summary, flux core is an electric arc welding process. It uses a consumable tubular wire electrode that contains flux material on the inside of it. Filler material is added to the weld automatically as the wire electrode melts. In self-shielded flux core, the weld is protected by the flux itself. And in gas-shielded flux core, the shielding gas comes from a high-pressure cylinder.